Welcome back to the show on static electricity. I asked you before the break whether a charged insulator will get discharged if passed over a flame. Yes, that's right. It will get discharged because the flame contains ions, and these ions will help the insulator to get discharged. Now it's my turn to address your questions. We have a student with a query. Let's see.
Hello ma'am, my name is Trijit. I have one question. A neutral metal ball is suspended by a string. A positively charged insulating rod is brought near the ball and the rod is attracted by the ball. Why does this happen?
That's a good theoretical question. A neutral metal ball is suspended by a string. A positively charged insulating rod is brought near the ball. The rod is attracted by the ball. Why does this happen? Since physics is real, why don't we demonstrate it? See, it attracts. This happens due to rearrangement of electrons in the metal ball. Negative charges are attracted to the positive rod and collect on the side of the ball facing the rod, and they leave behind positive charges at the far end of the ball. This process is called induction. Because the positively charged rod is closer to the negatively charged ball, the rod attracts the ball. Are you still trying to figure out the answer to the question I asked you in the beginning? Why does dry hair cling to a comb while oily hair does not? Here's the reason. Dry hair and comb can easily become oppositely charged with equal quantity of excess charge due to transfer of charge from one thing to the other after the hair is combed. Thereafter, the comb and dry hair will attract each other because oppositely charged things attract. In case of oiled hair, the transfer of charges does not happen effectively, hence we do not observe the oiled hair getting attracted to the comb. From insulators, now on to conductors. Let's take a look at an efficient way of charging a conductor. When a conductor with a net charge is touched with a neutral conductor, then charges will redistribute between them. Since like charges repel, the net charge will move around and distribute itself on the surface of the two conductors to stay as far apart as possible from each other. However, touching a charged insulator with a neutral conductor will not easily transfer large amounts of charges because charges on the insulators are bound to the atoms and cannot move freely in the insulator. An efficient method of charging a conductor is called charging by induction. Here's an example of charging by induction. We bring a positively charged plastic rod close to a metal sphere but not touching it. Free electrons in the metal sphere will get attracted to the positively charged plastic rod. Since free electrons in a conductor are free to move, there is a global or macroscopic charge separation on the metal sphere with electrons piling on the conductor surface close to the plastic rod and positive charges left behind on the conductor surface on the far side. This separation of charges in the conductor with the plastic rod close by but not touching it is an example of electrical induction. Alright, so far we have only talked about rearrangement of charges inside the conductor. Before we move on, let's take a question from a student.
Hello ma'am, I have a query. Is there any way to create a net charge on a metal sphere via induction?
Good question. Is there any way to create a net charge on the metal sphere via induction? Yes, there is. We can get a net charge on the metal sphere if we ground it after the charge separation. Grounding can be done after induction with our fingers or by connecting the conducting sphere to the earth via a grounding wire. Now you'd wonder whether it will matter where exactly the grounding wire is connected to the conductor. Don't let me catch you thinking that it will matter, because it won't. And here's why. In the case we discussed earlier, with a positively charged rod brought close to the metal sphere, grounding simply provides a mechanism for the positive charges on the far side of the metal sphere to get neutralized by attracting electrons from the Earth. So at any point, if we remove the grounding wire first and then remove the plastic rod, the metal sphere will have a net negative charge. Now suppose a metal sphere with charge separation via induction is grounded, and we first remove the plastic rod and then remove the grounding mechanism from the metal sphere. What do you think will happen? Don't let me catch you thinking that the metal sphere will develop a net charge, because that's not correct. In this case, there will not be any net charge on the metal sphere. This is because if we remove the plastic rod that causes induction while our finger or grounding wire is still touching the metal sphere, the electrons will run away from the sphere to the Earth. In Earth, they will be very far away from each other and hence will repel each other negligibly. We will not be able to trap net charge in the metal sphere if we remove the plastic rod before the grounding wire. Thus, it is important to remove the grounding wire first before removing the plastic rod, which is the source of induction, to create a net charge on the metal sphere. In the example we just discussed, we produced net negative charge on the metal sphere, provided we remove the grounding wire first and then the plastic rod. Is it possible to produce a net positive charge on the metal sphere in this manner? Of course there is. Here is the illustration of the process. Have you noticed birds sitting on electric wires and not receiving shocks? The reason is simple. They are sitting at a high potential, but the circuit to ground is never closed, so they don't receive any shocks. Is it time for some neutralization? Go take a break and zoom into our website topperlearning.com for even more electrifying topics than static electricity. And remember, coming right up is your favorite section, the exam decoded segment. Stay tuned.